It's our pleasure to welcome Eoin Woods, who's here today with us. Welcome at Code Camp, Eoin.
Hello, nice to be here. Thank you for the invitation.
Hello, Owen. Just yeah, I think it's us. We just turned the speakers louder. You were a bit the
Okay,
volume
can you hear me
lower.
okay now?
Yes,
We can
yes.
hear you. Okay.
Great. I do have a headset if we need it, but let's start like this and see how we go.
Yeah, everything works just fine for now.
Great.
So yeah, before jumping into the discussions and sessions, would like to thank everyone who joined today. Would like to thank our speakers and of course our partners who are Nagaro.
Microsoft, R Systems, and Cognizance of Vision.
And once again, best thoughts for our people in Ukraine. But let's now, jump to technology and think about how we can make it work for us, for the humanity. Uh, Today and tomorrow are dedicated to software architecture. Owen here, well, just triggers the conversation, and then we will continue the conversations about continuous architecture in practice. Right? Is it a continuous thing, right? So it's not something that we're doing upfront and then forget about it. It's a continuous.
That's what we're hoping. Definitely, yes. Yeah, there's always a balance. We can't just start without any architectural thought. But yes, the reason Murat and Pierre wrote the book originally, and then I joined with them for their second edition for the new one called Continuous Architecture in Practice, was this observation that when I started doing software architecture, because I'm very old with grey hair, when we started, most of the architectural work was done up front, actually. We produced lots of documentation about how the system was going to work. We tried to do lots of thinking about our risks, and we built prototypes. And then we did build what Philip Crichton calls a walking skeleton. We didn't try and build the whole system at once. We just kind of tried to put all the boxes in place in code and then start building out from there. But then it was pretty upfront. And of course, part of the reason for that was that we were building systems in a totally different way, and systems were being used in a totally different way. People didn't expect delivery of software every 2 weeks. That would have been thought to be an insane thing to try. I mean, if they got software every 6 months, they thought that was pretty racy. So the world has changed, and yes, unless it's not so much about changing the fundamental practices. I mean, quality attributes, quality properties, non-functionals, all the same thing. They're still really important. We've still got all kinds of people who care about the system, but in different ways, stakeholders. We've still got lots of things we're trying to achieve with the system, like maintainability or cost control or whatever it is, that are system level problems. None of that goes away. None of the techniques, like if you use C4 or if you use particular kinds of threat modeling for security, those techniques are all still useful. It's just that we need to start using them in a slightly different way, because if we do try and do it all up front, one, things are going to change all the time. So almost all the decisions we make at the front are probably going to be wrong by the time we have delivered much software. And secondly, people can't wait around for us. This is a challenge on a number of projects that I've either observed or been on at Endava, is that people need to start building, or at least they perceive they need to start building quite quickly. So they're not going to wait 3, 4, 5 months while all of the architectural decisions are made. You've got to work out which ones are the highest impact, the most dangerous to the project, the most empowering to the team. You've got to make those early and then let development commence, and then keep doing architecture right through the delivery cycle, so it never goes away.
So upfront and the so-called ivory tower are not today's instruments anymore, right?
Exactly. I'm sure nobody who comes to Code Camp was ever an ivory tower architect.
No, it's not that.
Such
Never.
people, we've heard of such people exist. Not in our companies, but our friends tell us that there were ivory tower architects. Yes, well, that's the thing. If you're going to do it continuously, you've got to be working with a team continuously. So you can't be disconnected. If you are disconnected, you'll become irrelevant. So that's a side effect, really. But it's a really positive side effect. I've always thought architects should sit in the teams if possible, or if not, just alongside, rather than be seen as some other group that does stuff and hands it over. But yeah, if you're going to do it continuously, you don't have much choice, do you? You're going to have to work with the development teams all the time.
Mm-hmm. And Owen, since you mentioned the Endava, which is part of some of the things that you're doing, well, you're occupying some of the space in your life. So I mean, tell us more a little bit about what you're generally doing. I know you're an artist as well. You're singing, right? Or you're playing some instruments and so on. So maybe you can share with us a little bit more. We're really eager to find out more about.
So briefly about Endava, for those who, I mean, you don't need to introduce Endava generally in Romania to a technical audience. People have seen our logo or even worked for us because we've got a very strong Romanian-speaking workforce in both countries. So Endava develops a lot of software for other people. We're a software services company, and we do a lot of cloud-native digital type systems, but we also take on lots of really interesting challenges with older software that clients bring us and they don't know what to do with it anymore. So we do a lot of assessment and then working out how to move older systems forwards. And of course, we do all the other stuff too, like we've got infrastructure architects and infrastructure engineers, and right at the other end, we've got user experience experts. So that's the kind of work we do. Not unlike some other companies, some of which you might have mentioned already today. But obviously, we feel that we're bringing a lot of unique skills to it. My role is CTO, which has got nothing to do with email, as I always have to explain. That's my colleague who's the CIO. She heroically makes sure that all of our IT services work. My job is to make sure that Endava's got the right capability in our engineering workforce that we produce great results for clients. We do that through a number of kind of things like we run capability programs to train people, and we organize our people into disciplines. You'll remember that very well, Florian. So we have developers, as one community, and testers as a community, and infrastructure people as a community, and creative services people as a community, and so on. And so we work through those disciplines to make sure that we've got great skills in our workforce.
And Eoin, all these responsibilities, do they leave you with any spare time?
Not a huge amount, especially because I've got a 16-year-old daughter. But outside work, my main interest is music, as you alluded to. Yeah, I play the trumpet.
Yeah, so nice, so nice. Good. Thank you so much for sharing all this with us. Before jumping into architecture and continuous architecture, I was thinking about technology trends and what's happening in the industry. Do you have any favorite, or are you keeping an eye on anything in particular? Maybe passionate about, I don't know, something.
Well, something that it's sort of a full circle thing. Something's happened to me is that I started my career having a lot to do with data, because one of my first employers was I worked for two companies actually. We were developing database systems, and then I did a lot of data work immediately after that. And then I sort of left data slightly behind and moved into architecture, and especially financial systems, which had data in them, but it wasn't primarily about data. The trend, which I'm sure everyone watching this is seeing as well, is that data is no longer seen as a specialist thing that only certain high priests of data will go off and build their magic warehouses and produce results normally once a month. Using data intelligently and getting more out of your data, and using tools such as analytical tools and machine learning engines on your data is becoming now really, really mainstream, and that's getting linked up to other things, because some kinds of systems, like systems with a lot of devices, like IoT systems or consumer mobile type systems, they've got a lot of very fine-grained data in them that I think, honestly, 10 years ago, we just have thrown it away, really, because it cost a lot to store and we didn't know what to do with it. And it wasn't very good for putting in a data warehouse because it was all very, very fine-grained. So, whereas now, providing you can afford to store it, and it's not free, everyone forgets cloud costs money too, but there's almost infinite storage available via cloud. So we actually can run lots and lots of sort of real-time type analytics, the sort of thing everyone's very familiar with, like, running Spark pipelines to produce a lot of derived analytics that you can then do something more sophisticated with off lots and lots of little bits of data. And that wasn't really possible before. So I'm seeing data as becoming something that is much more central to the everyday life of many software engineers and clients, whether that's people in your company who are using the system, or whether that's people buying your product if you're a product company, or whether that's people you're building software for if you're like Endava and others. Then people are just sort of expecting it. they're saying, well, we've got lots of data, so presumably now we can predict the future. You're going, well, not quite. But of course, we can do more with we used to be able to. That's why, in fact, at Endava, my group head of data, Adriana Calafarescu, is based in Bucharest. She's Romanian. So she's actually been running quite a big program we call the Data Academy. And it's not actually for the data people, because we have a discipline of data people or data experts. It's for everyone else, because actually we're having to make sure that people outside the core data areas know quite a bit about what you can do with modern data and modern data solutions, so that sometimes they call in, their data friends and say, we need some help. Sometimes they do it themselves, but that's becoming much more common.
So you're talking about, in a way, about data literacy, right? For like everyone.
Yeah, data literacy for the entire development team, really. Yeah, because there's big challenges for things like testing. And if you a tester who's come up doing lots and lots of work on testing APIs, very, very skilled automated tester, but if you then say to them, I now need you to test that all the trends in our derived data set are correct, well, that's like a huge challenge. Where would you start?
Absolutely. How about clients? How about customers? How do you? I mean, everyone now wants to become data driven. It's a not necessarily a hype, but it's a term, a syntax which is used.
Yeah, lots of companies say that they want to be data driven. I think you have to be careful what you wish for, because some companies are very data driven, and it's not necessarily all that pleasant an experience if you're completely data driven. But I've worked for one that was very data driven. I think what's happened is that there's a new generation of senior managers are appearing, and senior managers in their 50s and 60s aren't necessarily very aware of what the possibilities are. They're not sort of linking up what they're seeing on, their LinkedIn feeds. They're not sort of thinking about the analytics behind that and then thinking, oh, how about our business? Whereas there's a younger generation of the 30-something managers are just sort of coming up the tree now, and they're always known internet, and they may not know it's called cloud, but they sort of know there's all this capacity and processing just available. And they're probably far more literate about what software is and how it works and what can be done with data than the previous generation. So they're quite demanding. I mean, they say, well, LinkedIn does it. Why can't we do it? And often my answer is, well, it's because you're not prepared to spend $1 billion a year on IT. But the point is still a valid one. It's if there's all this potential to process data, why aren't we doing a lot more of it? And so I think that's partly what's driving it, is that there's a lot of business programs and business schools and so on have got these younger people in them, and they're starting to raise these questions and sort of thinking about what a data-driven enterprise looks like.
Speaking of generations, now we were discussing about business people who just got born in a world where dashboards and data was available and somehow ready to deliver insights and everything, and other generations who are striving to get in touch with the data and so on. So making like a parallel with what I read in your book, I very much enjoyed reading your book. It's really easy to read, although it's not a simple book to read. I mean it's easy to read it, but the content is really valuable there. Yeah, and one thing that I liked in particular is that I felt like it bridges somehow two worlds. Like the new architects who were born in the world of cloud, in the world of all the plethora of technologies around, and the architects who are trying to catch up. And those two worlds, in a way, kind of need to learn more about both sides. So the new generation has to, reiterate on the stuff that the industry produced, all the knowledge produced in the past 20, 30 more years, because there is a lot of value in there. There is a lot of useful structure, unless you get to the point where it's oversized or overweighting your systems and everything. While the other generation has to catch up with the new technology, new trends, the agility, so-called agility, try to re-understand their role in the organization and inside the teams or multiple teams, because it's been redefined. So yeah, your book is bridging the two worlds from my perspective.
Yes, I hope it does. And it's not just my book. Part of the reason it bridges that gap is that the three of us are, shall we say, closer to the ends of our careers than the beginning. In fact, Pierre Pur actually retired just as we published the book. So he was chief architect at a large American insurer, I mean, one of the really big ones, for probably 10 plus years before he retired. And he'd been at that company, many, many years. So he had very much been through that transition of, I think he started work on the mainframe, or if not very early Unix systems, and he ended up being almost entirely cloud native. And the other two of us, Pierre and myself, Murat and myself, we've sort of been through similar journeys. I'm a bit younger, and I probably have been exposed to more environments than the other two. So I suppose I had to adjust probably faster. And being in a company that serves other companies, we're always being pushed to think about how we do things. And Murat works for a very large bank and has for quite a long time. And similarly, that bank's going through these transitions. So that was one of the reasons we wrote the book. We thought architecture's got to change what it's doing, but equally well, we looked around for a brand new approach to architecture where the fundamentals, where the actual activities were different. We didn't find one. What we did find was lots and lots of mid-career. We found lots and lots of quite junior people honestly not knowing what architecture was still. I think because they opened older books and they went, this isn't very relevant because it doesn't talk about cloud. It doesn't have any architectural styles I recognize. Maybe, for example, there's a blackboard pattern, which is just as applicable now, but it's all explained in terms of, on-prem equipment or relational databases, and they've never used any of that. So I think, this is all very out of date. They put that on one side and they look around, and other than, very specific advice about, how to use AWS Lambda or something like that, they couldn't find much on architecture. So we thought what we need to do is to write a book that acknowledges all the useful stuff we've been doing for a long time, but puts it in a new context so that either a more experienced architect who's perhaps quite intimidated by the amount of change they've got to go through is feeling a bit reassured. Oh, so actually what I know is still useful, but I've got to talk to people in a different way. I've got to change my mindset. I've got to think a lot more carefully about how I work with the teams, but what I've got is still useful. But also for people who are just coming into it, try and not exactly reinterpret, but just represent architecture fundamentals in a way that doesn't look as if it all has to be done up front. It's only useful for monolithic systems. It's all got to be done on-prem, but actually modern, highly fragmented cloud-based systems need architecture just as much, or in fact perhaps more than the systems we used to build in sort of with 2 or 3 JVMs. So that's what we set out to do, and I'm glad that you picked that up from me. That's fantastic.
I really think this is spot on, because if I put it on the more general terms, I see this in teams that are, let's say, born in the Agile world, and there are some development practices that seem to be long forgotten, but they were valuable. Like you said, and they just need to be put in a new context. But that's
what I thought was so great when, who was it? One again of the very experienced people in the industry picked up architectural decision records and kind of reinvented them and said, hey, here's this idea. But, I'm sure he wasn't thinking, we have to capture this. I mean, I'm sure he thought, how did we used to do this? Like 20 years ago, didn't we used to check in text files with our code lines? And he kind of thought, I just need to explain it again in a new way that a new generation can relate to. And it's been brilliant. I mean, people are now once again recording their design decisions. Well, what's not to love?
I think if we open this topic, maybe you can talk about what do you think are the issues with architecture in 2022, let's say.
Where would you start? So I think there's still, despite the heroic attempts of people like Simon Brown, I think there's still quite a few people who equate architecture to the code layout. Code layout's important, and you could call it architectural. It is a concern, but actually it's in my view only one of very many concerns in architecture. So people need to think broader and deeper about what architecture is. In fact, architecture is irrelevant if it doesn't affect runtime or some other quality property you need. And an awful lot of the focus on code structure is healthy, but it only affects a couple of quality attributes, and it's normally maintainability and possibly extensibility. But the actual code structure often doesn't affect security, performance, scalability very much. It's what's inside that structure actually affects it. I have worked on terrible pieces of software that were very, very hard to maintain because they were just shoddily built, really terribly built and maintained. Yet they were really, really fast, very, very efficient, worked really, really well, very, very reliable. If you've ever looked, this is a few years ago now, but if you've ever looked inside the source code of Telnet, it's hair-raisingly scary. It's just, I mean, I had been programming for 20 years before I saw it. Had been an expert. It's all written in C. I had been an expert on C. I mean, I knew C really very well. I picked up the code to Telnet. I just gave up. It's just too hard to understand. On the other hand, that runs every single day, millions and millions of times, very, very efficiently, and does its job perfectly. So, yes, I'm not for a moment suggesting don't create maintainable code, don't think about your code structure. It's super important, but don't stop there, because that doesn't solve the other quality attributes. That's one of the things. I think the other thing is actually what we were talking about at the start is it's quite this continuous architecture thing. I mean, I find myself, it's quite seductive to say, let's defer all the decisions, let's just get started and let's kind of work it out as we go. And that sounds great. And it certainly, I suppose that's the ideal. The problem is that, as Martin Fowler said many years ago, architecture tends to be the stuff that's hard to change later. If you, I mean, pick a slightly silly example, but if you don't really do any architecture work about your data model, and someone on the team says, I've used Mongo lots, I think it's quite cool, seems to work, and everyone goes, yeah, great, let's just slap stuff into Mongo, and you end up with a lot of JSON documents. And then after a while, you realize, actually, you need quite a fine-grained data structure, and say you're solving some problems that are inherently cross-entity. On the other hand, you're dealing with an awful lot of data, so you're trying to minimize duplication, and you have a lot of quite complicated access patterns, and there's not much you can do to optimize them, but they just are complex access patterns. You need a lot of indexing. Without any disrespect to MongoDB, which is a fine piece of technology, you might well at that point realize, actually, a load of not very well designed JSON documents is not helping. At that point to go, let's just swap this out, reverse back, and use, Google Spanner, or at the other end, Oracle. Let's just use a relational database. Let's install Postgres, because we all know that one. To just do that, once you've got 30,000 lines of code wrapped around it, boy, is that a difficult, expensive activity, to the point where I've been in this situation lots of times where you should be doing something else. You're not in a good place, but the costs of moving to that, the short-term costs of moving to that better place are such that the people paying the bills, who are often non-technical people, are just not prepared to pay the bill. And they're just hoping that in the long term, some miracle will occur and things will get better. And they rarely do, of course. But I think balancing this, I suppose it's not so much even balancing early and late, it's timing your decisions. I think that's really difficult. I used to have long discussions, which I think were arguments really, with Sandra Mancuso. Sandra and I used to work together for a large bank, and we were in parallel groups, got on pretty well. We had very different views as to what was most important in software development. He was coming from craftsmanship, I was coming from architecture. Eventually, I think we did meet in the middle, and we did get along very well. But we had a lot of slightly short-tempered discussions about what the last responsible moment for a decision was. And Sandra's view was nearly always that it was much later than mine. And my view was, if you leave it to there, you won't be able to back out of it, or you may have more information, but I think it's a huge risk because other things up here will have had to make assumptions, and they'll have made poor assumptions because you didn't know what the answer was. So, and I'm sure he thought, bloody architects, they're trying to do everything up front. And I was in the back of my mind going, oh, software craftsmen, they're always trying to do everything at the last minute. And of course, all it was actually was a pretty healthy tension challenge between, well, no, don't do it all up front because you don't know enough. And perfectly true, I didn't. But if you, it's easy to spot the last responsible moment leaving in the rearview mirror, as somebody, I don't remember who it was, said most amusingly a few years ago. And once you're far past it, you realize you're in a bit of a mess, because what's tended to happen is not that nothing's happened, it's that a whole lot of parallel things happened. And so, for example, if you didn't decide how you were going to handle authentication and authorization, people will have put it in. They know it's important. You will now have 7 approaches to authentication, all perhaps using Auth0, but all in a different way, and all with nasty side effects when you bring them together. So it's not necessarily that you have to decide exactly how it works up front, but you do have to do it intentionally. I think that's actually the thing that I would stress to anyone is when you're trying to work out when to make decisions, just be intentional. You can't be right, but as long as you're thinking it through, then you're making the best decision you can.
Yeah, as a side remark, I was part of years ago of a team that we needed to, redesign an old legacy system. It was in the online payment space, and I was during a coffee break. I was sitting one of the guys, and he was saying, "Yeah, I don't mind if some things are done wrong, but then I look at 6 or 7 places, and they're done differently, and that's what killed me."
Yes. I know exactly what he means. Yeah, logging is my favorite example, where because I've operated systems as well as worked on them. Because in fact, most investment banks and many asset managers, they've been doing something that looks a bit like DevOps for years. They just didn't call it DevOps, and they didn't necessarily use all the technology today we call DevOps technology, but they did have you build it, you run it, and that in investment banks has been there for many years. If you build the software, you get called when it goes wrong at 3 o'clock in the morning, and there's a rota, and it's not negotiable. It's just part of your terms of employment, which is not always terribly pleasant. But I've been involved in a lot of operational incidents, and yes, logging across even moderately complicated platforms of sort of 4, 5, 6 components, never mind 40 microservices, but 4, 5, 6 quite big services, where each team's got a really good approach to logging. And each team's got completely different approaches to logging. So as soon as you're trying to work out even the log format, like one of them was writing seconds since the epoch, one of them is writing UTC time, one of them's writing local time, but they've handily reformatted it so it goes into some reporting engine really nicely. And you're now not sure what the columns mean because they've taken out the dashes between the bits and it's just numbers. And so you have to reverse engineer kind of what the date, the hour, the minute, and all that is. I had real situations of that, and it sounds so silly, doesn't it? That it's just logging. I mean, who can't do logging? But actually, without a bit of thought up front, you just end up with such a mess because everybody will do an intelligent job in their own micro context. And on a macro context, when you try and use it, it's almost unusable.
I think it's easier said than done because I think that's the challenge or the question, the difference between emergent and intentional, and what's the right time to make certain decisions. We all say, yeah, defer till last responsible moment or do things just in time. When is that moment? How do you know? How does an architect know when to?
And the principle is very seductive in a way, and even what we see, the very popular examples in the industry, for instance, the fitness, the wiki-based BDD tool, fitness is called, and there is a story behind that. They were thinking to choose like a relational database to store the things, and then someone very wise, of course, came in and said, "Look, let's defer it," and they deferred it, and and they realized in the end they don't need a database because it's a wiki-based system, and they're going to use like a file system, flat files, stuff like that. And that was it. And that's a very popular and very seductive example at the same time, but it's also dangerous because it can make you think, if you're unexperienced, that, deferring, it's without
It'll
being
always end well.
yeah. And it's also seductive because emergent design came up together with like the extreme programming thing, which was really cool and for tough engineers and so on. But in time, we all realize that emergent and intentional need to go hand in hand and
You
strike
need
a
a
balance.
bit of both, exactly. Yeah.
Exactly. So where we are in terms of architecture and DevOps, because DevOps it's a big shift in what, yeah.
That's a great question. Actually, funnily enough, I was watching a playback from another fine conference, not CodeCamp, but I don't even remember which one. And Dave Farley and Simon Brown were being interviewed on stage. And I can't remember exactly how the question was couched, but it was something along the lines of, what's the biggest change to architecture in the last however many years? And they obviously looked at Simon Brown. He looked at Dave Farley and said DevOps, which I thought that was quite insightful, actually. It's not an answer I would immediately have thought of myself, but actually, as soon as he said it, I thought, yeah, actually, he's right. Mainly because of side effects. In that, if DevOps implies a whole lot of things rather than states them, but some of the things it implies are the fact you've got cross-functional teams, the fact that you can release very often, the fact you can release early and but with low risk, the fact that you can build your system sort of from the ground up using automation through pipelines. So when you have all those slightly implicit environmental things, I think they push you towards certain architectural styles, and so I think it's a really healthy relationship. I think DevOps helps to keep architecture honest, and it helps to validate architecture repeatedly and all the time. And I think architecture helps to prevent DevOps becoming the kind of, as we were talking about, the sort of sprawl where, because you're empowering, it's more agile plus DevOps, you're empowering individual teams, and DevOps is given the ability to release very often. You don't end up with as much of an inconsistent sprawl as you would do otherwise, because you've not, to be clear, it's not telling the teams what to do. It's the teams collectively deciding what is it that's important enough to us that we are going to align on. And those are our architectural decisions. What will be hard to change later and what will have an impact on us. So what do we need to align on? I think the two have a strong relationship, but I think it's a very positive relationship. It's just that if you're going to achieve DevOps ways of working and get all the benefits from it, and you're expecting to get those side effects that people talk about, then that is going to imply certain kinds of architecture, such as, I hate to use the term microservices, but you're probably going to have smaller self-contained units rather than larger monolithic deployable units.
Mm-hmm. So DevOps, data, cloud, a lot of changes around that. So what are the key skills or key things that someone who's looking at, considering doing an architect role or taking care of architecture? I'm not sure if nowadays it's more about having the concern in mind and contributing than playing necessarily the role in a centralized in one person, although you need a person, especially in large teams. What are these skills? I mean,
I'm not sure that the core skills have changed very much. And my first answer to this is always very generic, but it's very, very important. And a lot of people find it very difficult, is you've got to be able to abstract. And I know that sounds sort of obvious, or software developers, we abstract all the time. Actually, I would respectfully suggest that very many software developers find abstraction very difficult, because when you look at their software, they don't appear to have found abstractions for concepts that they're working with. When you look at some of the frameworks that we work with, the people behind them are obviously fantastic at abstraction and modeling. They may not talk about it in those terms. It doesn't sound very cool, I guess. But if you look at parts of the Spring framework, for example, I'm always impressed how they manage to look at a whole lot of disparate technologies solving roughly the same problem in annoyingly different ways and produce a very clean, easy to use abstraction of the fundamental capability, and then only reveal the sort of implementation specific detail when you really need it, if you really need it. Otherwise, they just take care of it in the background by, using defaults or putting in adapters for you without you really knowing that they're there. But I do think it's not just architecture, but design and architecture. I mean, they're all about really getting the right abstractions at the right time, and making sure that the firm, well thought out abstractions and that you know what they mean, their semantics, to use another academic word, are really firm. And I think that's a really important skill. It's quite difficult to teach and learn, but not impossible. But you don't see too many books on abstraction, or not anymore. Back when I started out, you actually did have classic books really on software design, most of which are now out of print because they don't because they use archaic notations, and they talk about things like, or they don't talk about code at all in many cases, or they talk about things like Fortran. But there used to be a lot more. But I think, the best advice today is really, do I suppose read the books on design that there are, but a lot of them don't talk much about abstraction. But look for good examples and ask yourself, why does that work, and why is that good, elegant abstraction? And how would I have been able to create that? I frequently look at them and go, no, I wouldn't have spotted that. That's really, really neat. And that's the kind of design I really admire, is when people can pull that off. And then the other side of an abstraction, of course, helps you with understanding variation, spotting commonality. It helps you with understanding a lot of stuff at once, because you can think at different levels of abstraction. That's very important. The other fundamental skill, I think, is being able to communicate both, and it's just as important to be listening as well as being able to present. If you can't, I see this sometimes with good developers who want to move into an architecture career track, and I think we've really got to make sure you get some help with communication. And it's very, very rarely a language thing. It's nearly always that they just, in any language, they just find it a little bit difficult to really explain the core of what they're trying to communicate. Because if you can't explain your ideas very clearly, it's very hard to get people to understand them, validate them, and use them. And if you're not good at listening, asking good questions, pulling information out of people, analyzing that information and understanding it, it's very difficult to get the information you need to do a good job, because almost no architect knows the answers themselves. What their job is actually to find the answers from all the people who do know, bring it together, and then work out how to create a single form out of it. So I think, I suppose it goes without saying you've got to have really good technical knowledge, but assuming on this kind of call, everyone's going to have really good technical knowledge. The things that quite often people don't have are that abstraction ability, which allows you to understand, genericize, model, analyze, create good structures, and the ability to communicate both outbound and inbound.
And there's one particular thing that I've learned from you. Actually, it's the first time when I heard the syntax, the art of possible.
Mm-hmm.
What is the art of possible, Eoin? It sounds so poetic. It's but it's something that I know it's a pragmatic thing. It's a pragmatic attitude. It's some skills that you need to have in order to have this or master this art.
It's a kind of behavior or almost philosophy, isn't it? It's there's lots of ways of saying it. I didn't create any of these. I don't know where I copied them from, but there is, yes, being able to use the art of the possible. And not letting the perfect become the enemy of the good. What people really mean by that is that there is no perfect solution that's practical in almost any complicated situation. So you have to pick a solution that's good enough, but is also realizable, that you can create. I think it was me came up with a slightly jokey phrase that architecture is generally about choosing the least worst option from a collection of possibly quite unpalatable possibilities. That was the result of lots of practical work in large systems in big banks, where you're not normally starting from a green field. There's not enough time. There's not enough money. You haven't got quite the right skills in the team. You've still got to produce a solution. Even greenfield, actually, I find that you occasionally come across projects that have run into a lot of trouble despite being greenfield. And actually, I think in many cases, sadly, what they were actually trying to do was produce something perfect and very sophisticated. And so they didn't worry too much about shipping stuff out early and getting early feedback and getting early value, because they thought, well, we want to get just the right thing. It's going to be brilliant when they get it. And actually, they've ended up veering, it's in certain directions because they didn't get that constant, harsh reality check of putting stuff into production. And actually, they've ended up with something that's either too complicated, or it's maybe very sophisticated and very, very clever, but it runs really slowly, or it's much harder to change than they were expecting because the kind of change that they've had to absorb over time has changed. That they weren't predicting that. So I think that's really what the art of the possible is. It's about understanding that whatever you choose. It has to be something that you can build. I mean, to give you a good example, so a good friend of mine who I wrote my first book with, Nick Rosansky, Nick's been an architect for, I don't know, decades. And one of the things he always points out is that something he spots in, especially younger architects who are just starting out, they often get wrong is you've got to be able to build it with the team you've got. There's no point going, well, if we just had, I don't know, a reactive Scala team, then this would be brilliant. You go, well, maybe, but you haven't got a reactive Scala team. And even if they're enthusiastic about becoming a reactive Scala team, that's a massive risk you're running for whoever's paying the bills. So it's not to say you couldn't perhaps experiment with some of those ideas, but if you've actually got a really competent, relational database centric web development team who's been using, Spring Boot and Angular front ends for the last 4 years, I think you're going to have to think pretty carefully about using Java relational databases and Angular JavaScript UIs, because anything desperately different to that's going to be, really dangerous. And it's similarly actually in big organizations. It's less of a problem in a little one, but in a big organization, you've often got a situation where it's quite frustrating, but it's quite hard to bring in new, what you would call platform technologies. Things like we're all on Oracle and we have quite a bit of SQL Server and we have some Mongo. Okay, well, I'd like to use Neo4j. Oh, all right. Why? Well, can you just do it in Mongo? Or that looks a bit relational. Couldn't you do it in Oracle? And it's quite frustrating. You go, well, no, we're trying to innovate. We're trying to use new things. This is much better for the problem. The snag is, of course, is that you're not the only person affected. Because in a large organization, typically the platform is supported by a platform engineering team who don't know anything about Neo4j, and they've got no relationship with the vendor, and they've got no experience running it in really difficult situations. They've got no experience recovering it, making it resilient, failing it across data centers or cloud regions. They're not too sure what to do when a performance problem turns up. And of course, the app team isn't necessarily thinking about all those things. They're thinking about, I can use Cypher, and I can put my data in a graph, and it's going to be really easy to do, I don't know, geographical lookups. That's going to work brilliantly. But they're also implicitly often assuming, and then someone will take it from me, run it for me. When it starts running really slowly, somebody will sort it out for me. Actually, no, because the platform engineering team's going, that's quite a big job for us, and we haven't got any room this year to do it. So that's something which I think that's another example of where you have to understand what the real constraints are, and then you have to work out what's possible inside your current environment.
Yeah, actually, besides all the temptations that we all have as engineers, and we want to play with a lot of stuff, new brand frameworks and so on, I mean, we've got plenty of stakeholders around. So there are the obvious stakeholders, they are the most visible or the most verbose ones. The business wants stuff, they've got, I don't know, requirements, they've got interest, they've got, and they've got some money to invest, not always all the money that we would need. And that's one thing that we need to tackle, do the art of possible there. Okay, you want that, but it will cost you that much, or this is not possible in the constraints that we have. On the other hand, we've got another, major stakeholder, which is the engineering team.
Absolutely.
Okay, deal with that, and it's operations. Then it's, I don't know.
So to clarify, I think it's not about finding the best or striving to find the best solution or the best design, but finding the best or as good as possible the combination of trade-offs. And
it's because all the best, isn't it? It's not academically best. It's best in it with the real set of constraints that you're actually facing.
Yeah, and it's a continuous effort, which brings us back to the continuous architecture and the principles behind continuous architecture. There are like 6 principles. I thought about all of them thoroughly, but I need more. I mean, maybe we can tackle the principles behind continuous
Sure. Yeah. I mean, they're quite simple. I mean, like a lot of these things, like last response at the moment, they sound kind of easier than they are.
It makes sense, but
Sounds
putting them
promising.
in practice, well, practice is more difficult than, yeah.
Indeed, no good plan survives contact with reality. So the first one, so I immediately say these are not my principles. I think they're very good, but Murat and Pierre came up with these, and they're in their first book, which I knew them at the time, but they very much created them themselves. So the first one is about thinking about architecting products, not running projects. That's not actually particularly radical today. I reckon everyone on this call has just gone, yeah, and we know that, right? That's slightly historical thing, is that when they wrote their book 8 years ago, most this kind of move from projects to products was not a mainstream thing. In fact, it was seen as a slightly cranky Californian startup thing, which no serious company would ever do. But of course, now every serious company is trying to do exactly that.
So projects to products, and one of the disruptive trends that we see around us is not products. People don't want products; they want experiences.
Yes,
That's
exactly.
one of the disruptive things,
Yeah. That's
we're
perfectly true.
encouraged to look at. So, well, let's deal with that now. Huh?
Yeah, maybe that should be the first principle: architect experiences, not projects. Yeah. That's normally certainly outside my competence. I have some very clever colleagues who can create experiences, but I know my place. I can create the software which backs the experience. So that was the first one. It was really about stop connecting people together for short-term goals, driving them to a particular goal, and then scattering them all around, and then forming new people, possibly to change the same code. I mean, that is an anti-pattern you see in large organizations all the time. It's not that you don't form virtual teams to solve specific problems. I mean, if you've got a regulatory change in a bank or a pharmaceutical company, you'll want a cross-functional team across all the divisions to solve it. It's just that what you want is a representative from each of the product teams working together to work out what the end-to-end impact across all the products is, rather than people landing, changing systems, and then leaving again. And obviously, it's because you want to build organizational and tribal knowledge. You want people to feel a real sense of ownership, and you want to be thinking about investing for the long term. Whereas projects tend to be thinking about investing to get across the line and then not worrying too much about sustainability. Whereas if you've got a product mindset, well, you're in it for the long haul. So you implicitly think about sustainability because it's going to affect you. The second principle is focus on quality attributes, don't focus on functions. This is, I think this is almost a timeless principle in architecture, really. It's not that functions aren't important. It's more that functions tend to look after themselves. I've never seen functions forgotten, not in a big way. I mean, sometimes a product owner forgets a function, yeah, or a team implements a function wrongly. It happens, but functions just sort of happen because that's what everyone is thinking about. And also, quite often, functions can be implemented by one team or a couple of teams breaking a story up into a couple of pieces, and they can deliver the function. Quality attributes tend not to be thought about by people developing the features, the functions. They also tend not, and also they're often things which are very difficult to achieve on a team level. We talked earlier about security, logging, performance, scalability. All those things are actually things that have to be solved at a system level. I mean, there's no point having security for one bit of your system and not the other, assuming it all needs security. So that's why that principle is to, you've got to focus your time somewhere, so focus it on the quality attributes. And we see this a lot in the work we do, is that often the architect is a combination of doing practical work on the quality attributes and also being the kind of conscience of the team, constantly reminding them that you can't just add a load more data here and index it because it'll take a lot of space and it'll slow everything down. Or you cannot just add another 4 processing steps here because it'll ruin the user experience. Or, we can't use a singleton because that means we can't scale. And, all those kind of things, just reminding people. The third principle is what we were talking about earlier, which is about delay. And it's about delaying design decisions as late as you can. We've probably done that to death. It's probably obvious, but very briefly, the reason I put that in was, again, that although that was quite common in the Agile community, a lot of people in the architecture community actually said the opposite, which is, and again, 7 or 8 years ago, to manage your risk, you should make your architectural decisions as early as possible. and you could validate them by using a proof of concept or something. And we're at Pierre, we're just trying to point out there's a great danger with that. You'll be making a whole lot of decisions in a knowledge vacuum, and you'll probably end up falling back on experience and guesswork. Whereas when you're actually even developing the software, let alone operating it, you've got a lot more knowledge to know what's really important to help you make good decisions. For example, are we ever going to have to vary the system at this point? Well, that's quite hard to know up front. After 2 years of operation, you'll spot it.
You discover it.
There's loads and loads of change just here. So yeah, we need a variation point. Probably wouldn't leave it 2 years, but I mean, you might leave it till the third change, for example.
Yeah, I wanted to check with you regarding this principle. Some people relate this principle, among other things, to some sort of a cultural things. So people in various countries have a so-called adversity to uncertainty.
Mhm.
One of the side effects of being adverse to uncertainty is the need to decide now. If you decide now, you feel safe. You don't necessarily know more about the thing you just decide about,
Yeah.
but you feel safe somehow. And it proves that, yeah, in some regions, deferring the commitment, it's really difficult to achieve because of the cultural thing. I mean, have you encountered this point?
I've encountered that in the UK, definitely. It's like people have this saying, any decision is better than no decision. I sort of think, well, that really depends on the context. It depends on whether you need a decision right now or not. It might be a really poor decision. I suppose the way that I normally go behave in that situation is, the first thing is I try and see it from their perspective. Maybe they're right. Maybe this is such an obvious thing that the chances of us having to reverse it is so low, or the impact of us reversing it is so low that, yeah, let's just make a decision and move on. It's fine. If I really think that's not the case, then the way that I approach that is to just sit down with them and explain the costs, both financial and other, such as team morale, the costs of having to reverse this or just change this decision later, and why I don't think we need to make it now. The fact that actually it will only become important once, for example, until we've built the main transaction processor, it doesn't really matter how the archiving is going to get done, because we're not going to generate enough data. So I know we need archiving. I have a number of things in my head. I know we could do archiving certain ways, but I don't really want to decide how we're going to do it until we're approaching the point of having enough data to worry about. That's how I would normally do it. But you're right. In some cases, people, there's another saying people have, it's that they have a bias to action, which sounds good. Action's typically good, but again, in the situation, as we've been saying, if it sort of bounces you into making early decisions before you've got much information, then it's probably not actually a great idea. So
It's a paradox.
Sometimes people, as you say, want the decision for comfort reasons, and that's sort of fine. You could sort of make the decision. But what you might think about doing then in the team is, if you're very unsure, thinking that decision probably is going to change. We all feel better because we've made one, and we might be able to make that work, but there might be a better one. Well, maybe that's one to highlight and think about as you're in fact doing the functional work. Suppose we did have to change that because we're very unsure about it. Let's not hard code a lot of reliance on that decision. Now, of course, trade-offs are complexity and cost. Absolutely, that's not free. But if you're really not confident about one of your decisions, then obviously try and minimize your dependency on it.
I think it's like a paradox in a way, because, making a decision now, it's a sign of vitality, of agility. So, but no. Well, let's learn a bit more about the problem space, and then maybe decide.
Exactly. Yeah, it's short. It's a slight illusion, really, of short-term progress. It's a bit like Von Vernon's got. I think he got it from someone else, but he's got a funny saying about what is it? Sort of 6 weeks of non-stop coding can save as much as 6 hours of good design. And it's sort of, you get this. I find this a lot actually. People want to get their dev teams busy, And I understand there's psychological reasons for that, and there's financial reasons for that. And there's good reasons for all to get your dev teams busy, of course. But if you've got them all charging off in potentially the wrong direction, you're just going to spend 3 weeks, realize you're in the wrong direction, and then have them in 3 weeks reverse what they've been doing and head off in the right direction. So it can be an illusion of progress, and making decisions too early can be an illusion of certainty, and it keeps people's blood pressure down, as you say, but actually it can cause a lot of stress later. So it's worth trying to explore that with people and see if psychologically they can come to a bit of a balance for themselves.
Yeah, you're totally right, because I see sometimes people trying to start off kick off sprints, start doing work, and then at some point forget that velocity is not speed, right? It's speed and direction. If you don't have the direction, like you perfectly pointed out, it's counterintuitive.
That's a great, it's a great way of putting it. Yeah, exactly. You need the direction, otherwise you're not getting anything valuable.
Getting back to the principle, so change is the only constant of our lives, right? So change.
Everyone keeps saying.
Okay.
So he did read the book.
How
That's
do we
number 4,
architect?
right?
Yeah, how do we architect for change? What is the power of small?
Well, this was, again, I think it's probably quite a bit less radical today, but it's still useful to bear in mind. And actually, there's a trade-off around it, which maybe is the next level of sophistication to think about. It's that when Murat and Pierre wrote the book, microservices were a thing. I mean, people were talking about them. In fact, everyone was trying to build systems out of teeny tiny parts, and they hadn't yet hit the wall where it suddenly exploded in complexity on them. But what they were trying to point out to, I think what they perceived was very frequently when you're doing your sort of gross level system design, your architecture, it's tempting to have a relatively small number of relatively large bits connected together because it looks less complex. What you may be doing is simply shoveling the complexity into the boxes. That's quite common, but it looks, when you first look at it, it looks a very manageable complexity. What they were pointing out is what is just the whole sort of microservices principle, really, which is if you're going to change things very regularly, it's an awful lot. Structures made out of smaller parts are more flexible and they are easier to change quickly because you can change smaller amounts at once and still have meaningful change. So that's what they were pointing out. Of course, perhaps the next level of sophistication from that is choose the right level of granularity of your pieces for the rate of change you want to achieve. So because there are trade-offs. So if you build a whole thing sort of in teeny tiny services, or you build a whole thing using lambdas, you've probably, as long as you build it carefully, probably got something that you can change any individual bit anytime you like pretty well. But you've also got an awful lot of very small moving parts that unless you've got very strong intellectual control or structuring, it's very hard to grasp how the system works. And anyone who's chased, even a few years ago, anyone who's chased debugging through an event-driven system will know that that can be a very difficult environment to secure, to debug, to even to test as a system as opposed to the individual bits. It can be difficult to work out what's going on with scalability problems. There can be lots of hidden overheads, so it can be difficult to get the performance you were expecting out of it. So yes, it's got some really strong advantages. It's also got some potential trade-offs you need to be aware of. So I suppose the way you could restate principle 4 is architect for the rate of change you need. Choose your component size carefully.
Especially because you're not architecting stuff just for the sake of the architecture itself. It's for an entire life cycle of the product. You have to build it, you have to deploy it, you have to maintain it, you have to, I don't know, it has to survive all the challenges coming.
Yes. And
that's somehow one of the other principles that you based continuous architecture on.
That's what Principle 5 says, as you've skillfully alluded to. It's that Principle 5 is about it. It's extending what we said earlier. I mean, architecture is not just the code structure, but also actually architecture is not just what we think of as the traditional software architecture: components, connectors, quality properties. If it can't be built well, if it can't be tested and validated, if it can't be deployed, if it can't be operated, you're not going to get any value. So, and this becomes, given continuous architecture is trying to stress the importance of encouraging continuous change, then those things become really important. I always describe it to people who are newer to the industry as when I was in the industry in the early days, I first built products, which was a bit different. But when I was first building applications, you used to release your applications every 3 months or so, maybe a patch release once a month, but about every 3 months. Slower moving applications every 6 months, but say every 3 months. And it was always released over a weekend because, of course, nobody did anything at weekends back then. All systems were offline. So everything could be shut down and restarted. And that release weekend became the focus of everyone's attention for about 4 weeks beforehand. And if you were unlucky, about 2 weeks afterwards, as it really went really, really well. The reason, of course, for all this was that we weren't optimizing for release. Because we developed, 52 weeks a year or 50 weeks a year, whatever, but we only released every 12 weeks.
Yeah.
We didn't optimize for it because it wasn't really worth it. I mean, actually, 2020 hindsight probably would have been. Certainly for reliability, it would have been. But that was the way we thought about it. It's not worth building loads of tools. We've just got some processes and checklists, and it'll all be fine. And we'll package the stuff up using tar, and we'll FTP it across, and somebody will unpack it, and we'll run a script, and it'll all be fine.
And we all have like a hardening sprint before the release, right? So
hardening sprint, my favorite anti-pattern. Yes, yeah, yeah. We're going to have a non-functional sprint at the end to put all the non-functionals in. Good luck with that.
That's how it was. It was you're going to have the hardening sprint after the release, not before.
Yes.
Cut some corners before the release.
That's right. The date is looming, so therefore we're going to ship it anyway, and then we're going to put all of the non-functionals in afterwards. Yeah. So that's what we're pointing out. If you're going to move faster, if you're going to release a lot, and we're trying to embrace that, then all of these things which are after the software's been built are going to have to be optimized as well. So make sure that you create an architecture that can be released regularly, can be automated, can be validated easily, can be deployed effectively, especially in pieces. But also, actually, I mean, the architect's meant to be a skilled designer. Get involved with the people who are experts in those areas and make sure that the plan for automated deployment for your system really, really works well. So make sure you're enabling it by your architecture, but make sure that what's being planned for it is really good as well.
And last but not least, the principle that in a way, I read it like the reverse Conway law. I mean, make your organization, an enabler for the architecture that you want to build, for the product that you want to build.
Yeah, it's a kind of acceptance that Conway's law is a real thing. We've seen it happen quite a lot, so you might as well accept it. So therefore, rather than accepting that your software structures itself around your organization, structure your organization to create the kind of software structures that you're hoping to create. I mean, this in our book is really a pointer out to other people thinking about this. None of the three of us are experts on organizational structure, people dynamics, program management. I mean, that's why we all became architects. We didn't want to do all those things. But we've repeatedly seen where people are trying to create a complex software system with a structure, and they're insisting on doing it with a different organizational structure. And in nearly every case, it creates silos, it creates inconsistency. It's sometimes, I mean, it's a huge drag on velocity because people are constantly having to communicate across their teams, because of course most of the communication is in the team. They're constantly having to communicate across the team. The classic book everyone talks about, of course, in this is, you'll be surprised, Team Topologies, which is Matt Skelton and Manuel Pais's, and that's the kind of, it's not the only one. Some design books have got discussions about teams in them. Lots of the Scale and Agile frameworks have got a lot to say about how you structure your teams for your for effective software. But that's a great, very accessible book that, I mean, all three of us have independently kind of discovered and liked. So we're not the experts, but we do observe what we know enough to know what happens when you get it wrong. So principle 6 is make sure that as you're thinking about your architecture, you're thinking about the organizational structure. You may not be the person to define the right one, but you are the person that knows what you're trying to achieve. So you need to be working with someone who is really good at the organizational structure.
Excellent. Eoin, we touched quite a bit on data at the beginning of our conversation, but we would like to get back a little bit to it because I think it's such an important topic nowadays. with all the enablement that the data in the cloud provides us, with all the tooling around, with all the data lakes, warehouses, snowflakes, and everything. So, and
Missions.
also
Yes.
with the appetite of the organizations of becoming data driven, and with the McKinsey and all the others who are saying that data is more valuable than oil. So must be a big thing, right? I mean,
And oil prices do rise these days.
But to say, yeah, that was the case until a week ago. Yeah. I think there's two ways of thinking about data in the architecture landscape. I'm sure there's others too, but two major ones I'm thinking of. One is the fact that there are a lot more. So this is away from the sort of specialist data stuff. In terms of data technology, there's a lot more ways today to store data in a mainstream way. We talked a little bit about it earlier. There are, at least in the mainstream, there are relational databases, there are key value stores, there are document databases, there are network or graph databases. So that's very liberating. That means that we can think about storing different pieces of our information model in different forms and using a data store that's really optimized for it. That, coupled with the fact that, as we said before, we tend to build our systems today out of smaller pieces, having multiple database models may not be nearly as much of a problem as it would have been before. If sort of 10 years ago you'd said, I'm going to build a big JEE system with all in WebLogic, lots of lots of session beans, or session beans and message-driven beans. It's all very cool. It's quite modern, and I'm going to use a relational database, a document store, and a graph database. People would have just sort of looked at you and gone, "That seems unnecessarily difficult." I probably wouldn't do that if I were you. And so everything would have got rammed into the relational database because that was just what we did. Whereas the others now have matured, and I think people have reported experiences with them, and the vendors are now, have the backup for you, really, in terms of consultants and of more material and books and all the stuff you need, training, all the stuff you need to be a bit more successful with them. That we're seeing a lot more appetite, particularly for document-oriented databases, because they're really flexible, to pick the right data store for the right problem, and that's fantastic. That's a real step forwards.
I don't know, aren't you nostalgic about the old days when no matter how complex the system was, you only had one relational database, and that, universally used to handle the transactions between various operations for you? Wasn't that wonderful?
Wasn't it just? I'm still nostalgic for NCC. The world was a simpler place back then, but it's all changed now, so we'll just have to accept it. But no, I do think it's very exciting how much it's moved. I mean, I've been in this business about 25 years, and when I look at how we build applications, I mean, when I started as a system software engineer, because most application software programming then, frankly, wasn't very interesting. It was when I was a graduate trainee. I was being streamed off into system software, but I had to do some standard training. So I was taught how to build an application the standard way using Oracle SQL forms. That was how people build applications. If you think how we build applications today, and the power of the tools available to us, and the sophistication of the frameworks, and how good the user interfaces we can create really quite easily are, it's been an amazing journey. So I think we're all very privileged to be here. Wherever you got on the train, I feel very privileged. I've been on the train for quite a long time, not right from the beginning, but for quite a long time. But the other aspect of data, going back to data, is we touched on it earlier. So one, we've got more data models. That's super. The other thing, though, is that we've now got commoditized really big data stores. So again, not very many years ago, if you told people that you were going to hold 250 terabytes of data, again, they'd sort of look at you and go, unless you're in scientific computing, that does not sound like a very sensible idea, because that's going to be just so expensive to store. Now, actually, it's still not terribly cheap to store, because again, cloud storage costs can be surprisingly high unless you've got a special deal. But it's really that, I remember when, I'm sure everyone remembers when Hadoop HDFS, when that stack came out, and everyone tried to install it on dozens of small machines with local RAID disks, and or actually, you didn't use local RAID disks. HDFS did the replication, but lots of local disks, spin the thing up, load it with lots of data. It was really quite hard. in just getting the thing up was quite hard. And then I remember at the time lots of people at conferences talking about their experience with trying to do data analytics on it was hard, and trying to get data in and out of it was tricky, and load balancing across it was tricky. It was just a difficult business. And now you look at things like, Azure Data Lake, and they've done all the hard work for you. In fact, if you'd like Hadoop, they'll do managed Hadoop for you. They'll just manage the whole thing for you. They've done all the engineering. So I think what that does is it gives us yet another option, which is we've got these data stores in our system. It's now not cost or logistically or skills prohibitive to say we're going to have a specialist analytical store, and all of these specialist analytical stores are very well plugged in, for obvious reasons, into the vendor's data analytics services. Now, again, that's because they can charge you money for using them. They're not stupid. But it does give you options to, at much, much lower cost than it used to be, to build an analytical solution on the side of almost any system, even if it's on-prem, as long as it's okay to replicate into a private, not a private cloud, you know what I mean? Even if it's okay to replicate into a secured cloud environment, you can do it all on cloud. If it's a cloud native system, it's even easier. So I think in terms of data, those are really quite exciting trends. I mean, they're things that unlock a lot more potential. They also, of course, potentially unlock a lot more complexity. Just simple things like we've got 3 different data models, so we've got 3 different databases, and we've got an analytical system running on Google Cloud. How often is your data replicated? Oh yeah, quite a lot, because we already sort of replicated the document store quite a bit, because it's quite hard not to. And then we've got a lot of what's in the document store is in the graph store, because we need to navigate it. And then the relational store's got tons and tons of stuff because, I don't know, our standard reporting runs off that. So the enterprise needs lots of it there. And we replicate everything again up to our data lake, because we want to run predictive analytics on it. It's all very functional, but as architects, we have a responsibility to make sure that we're building something that is reliable, cost-effective, scalable, operable. Because, I mean, again, I'm a big believer in the DevOps principle. You build it, you run it. But realistically, there's very often, at least for some of the time, other people are babysitting our systems for us. So you say, Dan, I mean, it used to be, I've got an Oracle, I've got a WebSphere, I've got them both clustered, and we've got some Apaches. You look after it for us overnight, don't break it. Whereas now we've got all of these database models, all this replication going on. We've got all this stuff going on Google Cloud that we only mentioned to you last week and you haven't had any training on. Here's the credentials. If anything goes wrong, give us a call. I mean, that's really quite possibly we're breaching our art of the possible principle there. That is quite an imposing environment to use. So as architects, we need to think about the whole stakeholder community. That's the message really, is that it's easy from a dev point of view to go, that's very cool and looks very powerful. That's probably true. Can all the stakeholders who are affected by it adopt it?
I mean, some of the aspects that I find particularly difficult are the data governance. For instance, I mean, with all these data, traveling all sorts of systems, there's levels of processing, transformations, and then cataloging, so that you don't have like a huge amount of data lake, data swamp, And
Exactly.
then the lineage is also something that I find particularly difficult to achieve.
And also the data quality and monitoring data quality. Yeah, I mean, all of those used to be quite difficult. I agree, they've not got any simpler. And now, in fact, this new trend of the data mesh, which is trying to take decomposition principles that we've used on the compute store across to the data warehouse. I mean, you can see that they perhaps get even harder, because we've now got a load of different data product owners who are all going to have to do governance and lineage. And when you're combining it, you've somehow got to work out what the combined lineage of these different data products is. I mean, it's early days for that stuff. I'm sure some clever solutions will be designed, or probably have been designed. But I agree. I think those things have perhaps been exacerbated by some of these trends. And again, this is a sort of trade-off we need to have in our heads. But I think they always were there. I mean, I do remember, I was never a data warehousing person, but that was a whole subfield of technology. The people who used to run big Teradata data warehouses and all the reporting on the top. I remember them complaining about this back then, that it's really, really hard to know what people are sending us. It's very hard to keep track of what's in the data warehouse. It's very hard to explain to business people what the meaning of the different bits of the data warehouse are. It's very difficult to explain to people that although there's prices here and prices here, you mustn't compare them because they were calculated different ways. So therefore it's not reliable. You can use this as a group and you can use this as a group and not put them together. Business people going, they're all just prices. What's your problem? But no, actually, these are prices, but on a different currency conversion basis or something. So I think the data discipline, if you like, the data professionally, does have solutions to some of this. I think the problem they run into is a bit like where architects were a few years ago. Their answer is often move slower, think more upfront, add more controls. And none of that's in principle bad advice, but as we've discussed, it's quite difficult advice to implement today when the development team is now empowered by their continuous architecture to hurtle forward at lightning speed, to then say, well, you're going to have to fit into the corporate data model. And if you want to bring in a graph data store, we're going to have to work out what graph data governance looks like. And we're going to have to work out how to put graph data into the metadata, the corporate metadata store. I mean, the team is just going to go, no, we're just going to go on with it. We've got Neo4j installed already. We're pouring data into it every night. So I think that's the challenge the data folks have, is that they haven't really worked out yet how to be more reactive and more continuous. Once they're up and running, it's often quite continuous, but I don't think they've worked out how to adopt a continuous change into processes and tools that most of them have their roots in historical data warehousing, where change was a monthly thing or even quarterly thing. It wasn't a daily thing.
Yes, and then not to mention that now we have not so new kid on the block, but still new, which is yet another stakeholder for the data, which are the machine learning, pipelines.
That's a great point. Yeah, we're doing new things with it. Yeah.
And this brings me to another question about the new trends, the new technologies, the machine learning, artificial intelligence, blockchain. Well, how do they fit in the continuous architecture, or how do architects deal with all these new things, which are, some of them are still research. They are not production ready. I mean, there's an entire discipline which is just born, which is called machine learning operations or machine learning for production, because people played quite a lot with machine learning in the sandbox, where life is pretty decent. It's perfect sometimes, 99.9 accuracy, right? But then if you move that models into productions, then concept drift comes up, data drift, and then you have to iterate very, very quickly, which puts a lot of pressure on the data providers, the data lake, the data warehouse, the data business in itself. Well, what's your, I don't know, experience so far with this challenging aspect? At least this is how I find it now.
Well, I personally don't have a great deal of experience with it. I'm watching the whole ML ops, AI ops area with some interest. I think their problem is that a lot of people who are working in that area are used to have a fundamental background as data analysts. I mean, maybe very sophisticated ones, maybe nuclear physics data analytics with terabytes of data, but they're fundamentally people who've come from a background of working with a fairly set data set, doesn't change too often, and being able to work in their own workspace, and a lot of the and then taking the results and using them. A lot of the thought about how do I evolve the data set, in particular the question I keep asking, which makes me very unpopular, is as the data is changing in production, how do I know that the model is still valid? Any machine learning practitioner will tell you there are there's ways of both analyzing the data and testing the model that give them some confidence. But my impression is it's still, to some degree, an unsolved problem. And I think there's an awful lot of people who've come into the business via PhDs in astrophysics, for example. They're fantastic mathematicians, and they understand machine learning algorithms and the approach very deeply. They've then gone through a fairly fast-track career because they're in great demand and they can produce great results very quickly given a data set. They've ended up moving quite fast through the career path. And my impression is this is where the whole kind of MLOps thing has exploded from. It's they then kind of hit the brick wall of production, which was suddenly they weren't able to produce good long-term results with their models in production. And so the whole thing about model management, model validation, model verification, having machine learning pipelines and platforms, as they call them, suddenly became much more important. So say it's not an area I have deep knowledge in, but my observation is that we should be getting involved. There are definitely architectural aspects to it. We should be kindly pointing out where perhaps they're missing some of the feedback loops that we've learned the hard way in software development. But feedback loops are really, really important. And it does seem that part of the industry is working hard to work out how to keep it reliable, maintainable, and so on in operation. So I sort of see it as a parallel thing. Is that I'm sure there will be some software architects who work on the architecture of those platforms, and that they definitely need software architecture stuff there. But in terms of the actual data model difficulties, I think that's quite specialist stuff, which I don't think most software architects are going to be directly involved in.
Mm-hmm. Exciting conversation. I think we could do this for many hours, but I'm afraid we just have like 2 or 3 minutes to tackle one more final question. Sure. I'm being selfish again with my questions because I want to learn stuff. So Eoin, from your experience, if you were to build an organization which has a strong data capability, what do you need in order to do that? What people, what skills, I don't know.
Well, what we found is that there's probably 4 types of people involved, though often it's really 4 personas, and some people play multiple parts. A good friend of mine is the CTO at Faculty, who are a leading edge, quite small but very, very well-known machine learning AI consultancy in London. They take the astrophysics PhDs and put through the training. I mean, they're philosophically very much of the view that one person should be able to do all this, and they hire the most skilled people who are very adaptable. But I found that we have found that some specialization between them works quite well. The 3 that are probably most important are that you need data analysts who understand how machine learning works. So it's not, and that's quite a big step for many people who are today business analysts, who can do very competent work around data models, but they don't really understand how the machine learning models work. So therefore, they find it very difficult to do analysis on data as to what will be suitable for machine learning, how it has to be transformed, problems with it, how to spot things that will trip machine learning models up, worrying about bias in the data, worrying about skew, spotting the fact that certain data types are very unmodel friendly. They don't know any of that. So there's quite a lot of training for analysts to become specialist data analysts in this field. Then there's a fairly broad role, which is data engineering. And one of the things that we have observed is that sort of machine learning type engineers, they're people who really like to work with data that's reasonably predictable. Yes, they've got all kinds of tools for checking predictability, but they're not really great when you give them a heap of data and say, could you sort this out? That requires a lot of software engineering skills, which they tend not to have, and they get very frustrated with it because, of course, what they want to focus on is the model. So in the middle sits data engineers, and they're very broad people. I mean, they've got software engineering skills, they've probably got testing skills, they've got automation skills, sort of DevOps automation type skills. They've got a good knowledge of machine learning, probably more than the data analyst even. They know about all the common models, they know how NumPy and Python work, and Pandas works. They can do quite a lot of data analysis themselves, actually, if they had to, but they don't have a really deep knowledge of how to use machine learning algorithms to solve real problems. That's the machine learning engineer or machine learning analyst. But they sit in the middle and they're just invaluable. In fact, we find we need more of them than machine learning engineers, because there's always so much data that needs to be understood, processed, cleansed, transformed, packaged, so that the machine learning engineers are really efficient, that we've got quite a lot of them. And some of those people have come into the discipline from development. Some used to do sort of ETL engineering for traditional data warehouses, and they've expanded their skill set. And then the The other role which we're seeing sort of emerge, we're calling sort of data DevOps people. I hate the term DevOps engineer because I don't think there's any such thing. I think there's people who are expert at automation of various sorts of platform, but DevOps is actually something that is something which is a cross-discipline endeavor. But anyway, we still ended up, I think, calling them data DevOps engineers. The reason is because, remember we mentioned that there's all those complicated data platforms. What we found was that when you're into building and operating those, people who are used to building and operating normal application infrastructure and normal application middleware and all of that actually find them very challenging because they've got different characteristics. They're just not used to conjuring with the idea of 25 terabyte storage areas. It's just not something that they've specialized in. And a lot of the technology, Spark, for example, or Azure Data Lake, it's quite complicated and quite quirky all by itself. And it's got its own API and you use different automation tools with it. So we found there's a sort of specialization around automation, we've called a data DevOps engineer. Some people also have another specialization we don't have, who they call storytellers. We actually sort of merged that with the data analyst. Storytellers are the people who can translate the results for business people and sort of take the knowledge and apply it to become wisdom, if you like. Here's what you should do because of what we've found. But we've actually found that most people come out of the business analysis area and specialize then in data. They're great at that because they're great communicators and they've got a long background in understanding business problems. So actually, they're really good at bridging that gap. So we found that they can perform both of those roles.
Brilliant. What else can I say? I mean, always a pleasure to have all this conversation with you, Eoin.
Always a pleasure to be.
And any final thoughts for the architects out there or for engineers who do care about architecture and technology?
Keep thinking about non-functionals, keep thinking about stakeholders, and keep abstracting.
Well,
sounds simple.
Easy. It's easy.
And at the right time to make decisions will come.
Exactly. That will just come naturally.
Eoin, I think this leaves us 4 minutes till your next meeting, right? So thank you so much for taking the time and for
You're welcome. Thank you very much. It was great to talk to you again.